All right, I went ahead and started the recording. This is part 2 of a lecture on this chapter 8 in the C# curriculum that we're going through. And, part 1, we did a semi, I would just call it a semi-deep dive, kind of medium level dive on arrays. And so we covered a lot about arrays and how they work and all the different inner workings of arrays. And so, I would say that was more than just introductory. That was kind of somewhere in, it wouldn't necessarily say it's advanced, but at least mid-level concepts of array. So where we left off are these different, these are just different ways to store data, and they're called collections. And so arrays have been around, programmatically speaking, since some of the earliest programming languages that I've ever studied, probably well before, I would say the oldest language that I've studied for my personal is C++, right? So maybe some of you have seen or taken a C++. I took C++ in high school, and C++ has been around, with a long history. And so that's maybe the oldest language that I've studied. And certainly arrays were a part of C++. And so they've been around a long time. But because they're kind of also older, they come with some inefficiencies. We talk about arrays and their benefits, but we didn't really talk about their downfalls. And as you got into arrays and we started getting later into arrays, we started saying, hey, if I just wanted to create a copy of arrays, that there's a bunch of different ways that you can make a copy of an array. It's not something that, copying is one thing with array.copy. But then also, from those of you who came from JavaScript, one of the questions that was asked was, hey, can't an array just grow in size? Like if you add another one, can't it just become bigger? And as it turns out, the answer was no, it can't just grow in size. You kind of have to, what you say, you dimension the array. You say there's 100 things in there. And if there's more than 100 things, then that's not a problem, but you have to code it. You have to solve that problem, right? So we can call it a problem, and there's ways to solve that problem with arrays, but they're not necessarily that easy. And so the other thing is what if you say, hey, I've got an array with 100 things in it, but you don't know how many things there are. Maybe there's only 50. And so you've got storage. You got storage for 100 things, but you only got 50 things stored in it, so you got a lot of wasted space. And so, those are some of the shortfalls of arrays where it's hey, you dimension an array and then you got more things or you got less things, and how do you handle those problems? And so that's really where some of these collections come into play. To be quite honest with you, the first collection that we look at, this concept of a list, and a list can be typed. This is something called a generic. And what that means is you can put a data type on a list, like a list of strings, for example, or a list of ints, or a list of chars. But lists are very common. Okay, lights decided to come on. That's nice. I guess it was not a good connection. Anyways, lists are very common in C#. In fact, they're just super common. And so highly recommend gaining some exposure in the class to lists. Keep one on, please. Thank you. So definitely want to get some exposure to a list. You can kind of read then about a sorted list. It kind of just makes sense if you know a list is just a bunch of data and you can be given a type. A sorted list obviously is going to be sorted in probably some alphanumeric order, and it can be used to quickly look up data. And so they kind of go through here. When you have a sorted list, it uses a key to access a value. So we'll get in. We'll demonstrate this. We'll write some code on a sorted list. Uses a key to access a value, which can be any type of object. Can be inefficient for accessing elements sequentially. So if you're going one at a time looking for a piece of information sequentially, but it is very efficient for inserting elements into the middle of a list. So as you start working with lots of data, then operating on that data, it becomes important. Like, depending on the data depends on the type of structure you might put it in, because all of these different structures kind of have pros and cons about, well, is it fast for reading? Is it fast for writing? Is it fast for updating? You know, there are these different collections that all kind of have their pros and cons. Okay, so we got a list, which is a way to store data. We've got a sorted list, another way of storing our data. We've got this thing called a queue, and we've got this thing called a stack. And so again, you know, when might you use a queue? When might you use a stack? When might you use a list versus a sorted list? We'll kind of jump around those topics as we're going through. And I think I left open Chapter 8 solution. And this is where we left off. Right now, you know, we had a bunch of employee names, and so all of this is stored in an array. And so the first thing that we're going to study is the list. In order to use a list, you have to have a using statement here. Now there is one called an array list versus a list. And so you notice slide 48 and slide 49. You'll notice that an array list can have an untyped collection. What does that mean? There's no data type. And so similar to JavaScript, when you could say, hey, I want to add a 3, I want to add a string. So here's an int, here's a string. Just looking at this, what are you noticing? To put data into a list, we're using methods. Instead of with arrays, we were using subscripts, right? We were saying sub0 equals sub1 equals sub2. So with these collections, the first thing, we're going to have this using statement up at the top. Like, let me just try, and we got an array list called names. And so you see this kind of barks at us right off the top, and it says, hey, we don't know what this is. We don't know what an array list is, and you can click on show potential fixes, and it'll even tell you to add this using statement up at the top. Now, what is this? What is this using statement? This is an important question that you should all know. What is this using? I want you to imagine there's a folder called collections inside of a folder called system. Okay, so these are just folders. And as it turns out, this array list it's called a class. It's a class that's coded inside of this collection folder. And so in order to use an array list, you basically just have to tell C# what folder to look in to find the code that declares and defines what an array list is. Now, I use the term folder, which is basically what it is, but the fancy programming term is called a namespace. Okay? But think folder. Okay, so this is really the collection's namespace. And inside of this collection's namespace, there are a bunch of classes. ArrayList is just one of them. In fact, I think you could, yeah. Okay, so you have to have this in here basically to tell the compiler where to look. Okay? So you've seen this syntax before. Specifically, I'm thinking the random class. Random RND equals new random. Okay? Something to point out here. Anytime you see the keyword new, we're creating an object. Okay, so we're creating an object. The data type is an array list. We're creating an array list object. It's called names. Now we could just say names.add Jan. And we use the methods What's the benefit of an array list? Well, I kind of gave you the hint earlier, is that it can grow and shrink in size dynamically. So you're not wasting space in RAM. That kind of can happen with arrays pretty easily. Okay, it's also, because of this, this is as the lecture says, this is not typed, and so notice I could just add. I could add strings. I could add ints. I could add doubles. I could add all sorts of types. Now I can use a for each loop to print it out. Remember the shorthand for each? Now because I've got both strings and ints, I can't change this var to be a string or to be an int. Var is actually, and they cover this much later in the book, but it's basically a loosely typed variable declaration. You're like, I don't really know what type it is, so I'm just going to say var. And because names has many types, I'm just going to say, hey, var. And now you could see it prints out each piece of data. And because it dynamically grows in size, it's just going to be 3 storage units. We don't need any more, no less. It's dynamic in size. And so you could use a for each loop. You could use a traditional for loop. There's, using the subscript. All the things that we learned before about, averages and all that fun stuff. Yeah.
So then, is there like any disadvantage to using a list rather than an array?
Well, the big thing there is kind of what I was saying earlier, is that it's dynamic in size. It can grow and shrink appropriately. So, every variable takes up RAM. And so you don't want to have a bunch of unused variables. If I were to do something like this, int numbers, and let's just say, you're going to get user feedback, right? So we're going to ask the user for numbers, but you don't know how many ints are going to be. So you might dimension your array to be 100 numbers. Well, they might only give you 5 numbers. So you've wasted 95 integers of space in your RAM. Right? And here you don't need to do that. You don't even need to dimension your array list. Now there are some defaults, and if I remember correctly, an array list is dimensioned automatically. I want to say 10 elements, and then if you go to the 11th, then it'll double to 20. So if you add an 11, it'll double. If you go to 21, it'll go to 40. If you go to 41, it'll go to 80, right? But then there's also methods like this. So instead of wasting, if I'm telling you that this array list has 10 elements of storage by default, this will trim it down, meaning get rid of the unwasted space. Yep.
So
That's why they're so popular. There's not major drawbacks. They're kind of the new array, if you will. Arrays exist. People use arrays. There's really if you understand them very well, then they're fine. So you got to understand arrays, but the newer approach is going to be a list. Now, this one here is an array list, and if you wanted to give a type, I believe you could do this, at least. No. So, there is a way to do that, but in C#, it's confusing because there's an array list, and I believe there's 2 versions of this class. We're not using the other version. But, okay. That's an array list versus a list. An array list without a specific type. But if I want to say list of string, employees equals new list of string. So this is declaring an array list. This is declaring a list with a specific type. These angle brackets here, a lot of times you see the syntax, which is T, which means it's a generic type. You could put a data type in there. And you could see here a list can have a specific type. Now, you might have saw kind of how we learned how to declare an array and then put data in using subscripts. Or you could do this, what's called an array initializer. If you know the data, you can initialize the data into the array right away. And we did that. You could do the same thing with a list and with an array list, actually. And you even kind of saw that syntax. With this. And I want to say don't know that that's necessary. Let's get it right. There it is. So this is a list initializer. And notice, it's kind of the same syntax there on the array and on the list. And so, I'll do this a lot as the class goes on. We'll be putting data in lists. And I'll just be initializing the data kind of with a list initializer. This is an array initializer, a list initializer. But notice here, because this is a list of strings, of course, we're not able to just put in an int. That should cause a problem. Yes?
So we use that for each and did a console.write line. What if you only wanted to output like just Bob or like, Jan and 7?
Okay, good question. So you can actually do names. You could use a subscript. So if you just want to access one item in a list, you can treat it like an array and use its subscript. So name sub 0 would be Jan. Good question. Right? And if I say name sub 2, 0, 1, 2, that should get us the data of 7. And the same thing kind of here. Employees is our list of string. Employees. Now this should break, right? So let's see our error message there. Index was out of range. You've seen that before. Actually, what happens behind the scenes of these methods is, well, we don't need to. I don't need to get into that. Okay, so that's a list. That's we're going to use a list. We're going to use lists a lot. Let's kind of glance at the methods because these are important. So I demonstrated the add method. Pretty straightforward. We got some properties. Remember, properties are just pieces of data. Count versus capacity. Capacity is how many elements you can have, right? How many units of storage are there by default? And so I kind of mentioned that if I was right, that a list has a capacity of 10 by default and then it grows. So let's just do this. Let's just do employees. Let's see if I was right. And it turns out I was not. So the capacity by default is 4. So now let's take Jan out. It must have been Java that was 10. So it doesn't really matter. The capacity is 4. So that, you know what that means? That means it's 4 units of storage. Okay, so let's put a 5th in there and see what happens. Let's put in 5 bobs. 1, 2, 3, 4, 5. So now we got 5 bobs. And now we're going to take a look at the capacity now that we've grown bigger than 4. And okay, so the doubling does work the way I described. It was just my initial number was wrong. Okay, so it goes into go 4 to 8, and then of course if you do 9, if you add a 9th element, that's 5, 6, 7, 8, 9. You can see the capacity doubles. Okay, so again, capacity, total number of storage. Again, I just think of it like a storage unit, right? We all have rented storage units before. You know, how many things can you put in a storage unit? How many things can you put in a storage unit? That's capacity. Right, so then the other property is the count, which is how many things are actually in there. My capacity is how many can you store. My count is how many things are actually in there. So if I replace capacity with count, you can see I've got 9 elements in there. Now, let's kind of trim this up a little bit. We got a bunch of bobs here. Let's do employees.clear. Well, pretty safe to say what happens there. So now we put a bunch of employees in and we print them out. Now our count goes down to 0. If we wanted to put one back in, employees dot add Jan string. Okay, 1. There's also add range. All right, now this is interesting. It takes in a collection of strings. I got like an array called employee names. Let's just pass in employee names. So our list can take other collections if we add a range. So now our employees should be the same list as employee names. And to demonstrate that, we'll do a for each var item, for tab, or for each. I just typed that for. You can tab down. This is your snippet, right? So tab. It's going to get you your for var item council. So here we're using the add range to accept another collection. And here we print out each item in the collection, in our list in this case.
So you just converted an array into a list there?
Yeah.
Basically?
Yeah. Yep, took our array and put it into a list.
Which makes it easier to work with.
Which could, yeah. Yeah, from a programmatic sense, it is a little bit easier. So those are some very useful methods there. Of course, we got some more methods. Let's see. Contains returns a Boolean value that indicates if a list contains the object. So let's do a console.writeLine employees.contains method string item. Just say Jan. So this is going to say true or false whether my array contains the object Jan. Now, luckily that worked. You would expect it to. Sometimes it could be weird depending on how the comparison is done, but I'm glad that worked. So this returns true or false. Maybe you would say if employees dot contains Jan. You could use it in an if statement, right? Because it returns true or false. Now you could say, okay, console.writeLine, Jan hasn't quit. The great resignation, Jan has not quit. Yeah.
Is that the same as string.contains? I know we have something in our lab like that.
We're going to get to that. Yeah. Good question. Is it the same as string.contains? Well, the same concept, yes. Right? So you're looking through a string for a certain piece of data, or you're looking through a list for a certain piece of data. Right? A string is a single piece of data. A list is a bunch of data. So same concept. Yeah, good.
I'm still kind of a little confused on like Arraylist versus a list. Are they the same thing?
The big thing here is that Arraylist we did not give a data type to. Arraylist comes from Java, and so this is something that, again, remember C# is kind of like a combination of Java and C++. And so this came from Java, but the big thing on this, it doesn't have a data type, and this one does. So here we could add all sorts of types of information. So let's talk about, let's take that a layer deeper, one layer deeper, okay? Do you want data types? If it kind of depends, yeah, that's it depends.
I mean, if it could do it for you, that's the best way, right? It's automated.
So the one thing is, hey, this is a little bit more automatic. You're just adding things, ints, doubles, chars, floats, and doesn't really matter. And the program handles it for you, so that's nice. So that's an argument against having data types. But as it turns out, the more you work with lots of data, it can help to understand the data. So if you've got this list, what's in that list? Is it names? Is it birthdays? Is it dates? Is it a list of students? By the way, you could have list of objects, right? So is it a list of students? So I want you to imagine this storage container, right? And one storage container only has, I don't know, one type of thing in it, and that is numbers, right? So you got these numbers, and so you could tell just by looking at the storage unit, you got a bunch of numbers in there. You can understand the data when you have data types, okay? When you have untyped things, like array lists, you're like, I don't know what's in there. It could be dates, it could be objects, it could be names, it could be, who knows, right? So it makes it a little harder to understand your data when you're untyped. So for me personally, I like to understand the data. I prefer the types, you know. But there's a lot of languages, be it JavaScript, that are called loosely typed language. They just, you put everything inside of a let and it just handles it for you, and that's kind of nice. It just kind of handles it for you, except for when it doesn't, because it doesn't always. Well, so Vinny's, to Vinny's point, I like when it's automated and it just kind of handles it for you. I would agree. But there are cases when it doesn't, which makes it kind of hard to understand.
Would it be, is this method more efficient as far as performance if you do array list plus print the size?
Yes.
As opposed to
the array. Yeah. So I think of it like a hierarchy. Like putting data in arrays is better than just putting it in a bunch of separate variables. An array is a storage unit that's going to give us some efficiencies, right? And a list is better in many cases than an array. So it's just like tiers, like one's a little bit better than the next. And so basically what that boils down to is most programmers use lists a lot. You use lists a lot. Yeah.
With the array list, would that be something you probably tie into like an event handler? So you enter a bunch of data and then you can assign it to whatever array or a list?
So the question is, let me make sure I understand it. So an array list, yeah, would you tie it into an event handler so that you are using it on an event as opposed to, the answer is yes. I mean, you could most definitely tie it into an event-driven architecture.
How would you code it to like get user information?
How would you code it to get user information? Great question. Let's just use our list example, right? In the most straightforward demonstration, right? I'm going to read line whatever the user types and pass that to the add method. Put that inside of a loop. Gonna have to change the language briefly, right? And then now I need to test for X. So let's get our loop going here. Okay, and then instead of adding, because we don't want to do a read line if it's X, right? We don't want to add X. I'll say if I'll say emp name, if emp name not equal to X, else break add emp name. Making sense? So let's ask for a name or X to quit. Let's read the name into a variable, test the variable for X. If it's not X, then we add the name, otherwise we break. Outside of the for loop, for each, tab, var item in, this is employees. Console.writeLine item. I would say for var employee, and because we know that these are strings, we can change this data type to string. For each string employee in employees, print out the employee. Is that kind of like what you're looking for? So Debug, start without debugging. Bob, Tim, Jan, X. Spits out Bob, Tim, Jan. You could put in elements at certain positions. So if you got 10, you got 10 elements, you want to put it in position 5, you could put it in position 5. You could remove Jan, right? So let's you could remove Jan. So I keep using Jan. So employees, I'm gonna remove a single capital Jan. Right, so I want to fire Jan here. So employees.remove Jan, debug, start without debugging. So Jan's going to be my first employee. Then I'm going to add Bob and Tim. X to quit. You can see Jan has been removed. These are the functions, right? When you have a bunch of data, what do you need to do with that data? Well, you need to manipulate it. You need to edit it. You need to remove it. You need to add it. Oh, maybe we need to sort it. Let's do employees.sort. Ryan, go ahead.
Could you put in like what you're doing now with the employees.sort or remove? Could you put that into like a button click? So when you click the button, you remove.
Yeah. So now we could see I got Jan removed and we've got sorted data. Yeah, you could do it on a button click just as well. So what you could do is say, hey, here's a list of employees. Here's our 100 employees. Maybe you would provide a search. Search for an employee by their ID number, right? And then when you click the delete button, you delete that employee with that ID number. So yeah, it's much more event driven, and I think that's kind of what Jonathan was getting at, if I understood correctly. So there's our arrays, array list, I should say, and our list. Data collections. Yes, sir.
I don't think we went over this, but is it like in JavaScript, when you create an object for an array, can you assign different attributes to the specific object within an array?
Mm-hmm.
Like in the case of the employees, you have your first name and your last name?
Mm-hmm. We haven't quite gotten to that, but yes. So the question is, like, when you have an object, and your objects, they have properties, like employees have first name, last name, social security numbers, etc. Yes. To do that, you have to create. So in JavaScript, we just had we could just make objects and they had properties. Here, you have to use what's called a class. Before you can make an object, you have to create a class. And so we would have a class called employee that you would define those properties in. I think that's 2 or 3 chapters from now. Okay, so that's that. A sorted list. Again, kind of going back to the benefits of a sorted list. Sorted lists, if you need to do an insert, I always think of CRUD operations, right? CRUD, C-R-U-D. So you got a bunch of data. What are the operations you perform on that data, right? You're going to hear me say this 100 times. CRUD operations are your basic operations on data. So now that we have collections, we're going to start doing CRUD operations on collections. CRUD meaning create new data, read data, so like you've got 100 employees, you're searching for one employee, right? So you're reading data, you're updating data, so Jan's last name changes because she got married, so we got to update Jan's record. And you're deleting data, meaning Jan got fired, so you delete her. Okay, so CRUD operations are very normal operations, and if you're kind of wondering, like, what's the benefit of a sorted list over a list? They spell it out right here. Sorted lists are not great for reading items sequentially, right? So when you think of CRUD operations, if you're going to search sequentially one after the other, okay, sorted lists are not great for reading sequentially. Okay, however, if you want to put in create, that's the C in CRUD, you want to create a new piece of data and insert it into your list kind of in the middle somewhere, not at the beginning, not at the end, because there might be other collections that are really good at adding things to the end. You want to create new data and put it in the middle. That's where a sorted list comes in. And so this is really interesting because remember in a list, you want to read out like what's in position 3. You use the index just like you do arrays. Well, when you're reading out of a sorted list, you don't use the index. So let's do a demo of a sorted list and you'll see what I'm talking about. So here's the syntax for created a sorted list. You notice that there's 2 data types in the angle brackets. And so these are known as key and value pairs. The value is the data. The key is how you look the data up. So let me do my demonstration of a sorted list. So we're going to say using system.collections. So I can have a sorted list. Sorted list. Now notice the sorted list takes a key and a value. Now these are the data types. So my key, I'll make it an integer, and the value will be a string. So here is my collection of students. Each student will have an integer, be it their student ID, this is where I'm going with this, and a string which is their name. So if I say students dot add student ID of 1 is Josh. Students dot add student ID, now 1's not a good student ID, we'll say, student IDs or something like that. And we'll say student with an ID of something like that will be Bill. And now, keep in mind capacity. Let's see what the capacity is. Very similar to the list. The capacity starts off with a default of 4. Remember, that's this, default. If I wanted to change that, you could put the capacity at, 10 to be default, right? So now you can see the capacity changes to 10. So putting a number here changes the default capacity. Okay, you leave that empty, it's going to be 4. What if I want to look up Tammy? So you could ask the user, give me your student ID. And if I'm going to look up a student by their ID, I would say students sub, I'm going to do this, console.writeLine, enter your student ID. Int ID equals convert to int32 console.readLine. Student sub ID. So I pass this ID, and this is how we're going to do the read operation. We're going to be able to read by their ID. So instead of using the index, meaning the position in the in the list, to an end user, the position in the list doesn't make any sense. Right? So this is actually kind of cool because this is the first time, this is called an indexer, right? An indexer is some other value besides your position in the list that you can look up data by. So Tammy is 10,000. So let's see if this should work here. Enter your student ID 123, and we get back Tammy. So when we pass the indexer in brackets, then we're returning, what we get back is the data. The data is the value. So the key is how you look up the data, your indexer, and the value is the data itself. Yeah.
So how would you do, like let's say they messed up and they typed in like 10,001, how would you display an error message to them?
Sure. So if it's not found. So let's just see what it does right now. Let's just say unhandled exception 1234 is not present. So that's a really good question. So let's look at some of the methods that come along with this. Contains key returns a Boolean value that indicates whether or not the sorted list contains the specified key. So let's see if we can use this. Again, Boolean, it's going to return true or false. So I would say if students dot contains key of ID, then let's print it out. Else you with me? Great question. Let's see now.
So the key is just like the numbers, basically.
Yeah, so the key is how you look up the information.
Okay.
The information is what's after, it's after the comma.
Got it.
And here where you define the data types. So here I'm saying my keys are ints, my data are strings. Yep.
Do you make your keys strings and your
Yeah.
data ints?
Yeah, sure.
It's just whatever comes first.
Whatever comes first. That is correct.
Okay.
This could be string.
Right.
It could.
Stricker.
On that note, let's take a break. I'm ready for a break. All right. Go ahead and click on resume. So if you guys would kind of come back in, and I probably should have opened the lecture with sharing this link, and you guys want to go ahead and click on it and follow it. So Microsoft documentation is a really good resource for this class, and so it's docs.microsoft.com and C#. So it's .NET documentation, and so they kind of come into here. This is an article that was written last year, and they talk about generic collections versus non-generic collections. Okay, which we've talked about, array list versus list. But what I like about this article, more than just reading, they talk about common collection features, capacity and count properties. We've seen that. There's a little section in here that says choose a collection. And so this is, in my opinion, something that you could throw on your bookmark and say, hey, I got a bunch of data. I need to put it in something. What would I consider putting it in? What collection would I consider putting it in? So they have this scenario. I want to store items in a key value pair for quick lookup by key, which is interesting because we just learned a sorted list that basically has a key value pair, but there's also this thing called a dictionary. They being Microsoft, recommends if you want to look things up by key value pairs, instead of using a sorted list like we just demonstrated, you'd use a dictionary in the same capacity. Okay, there's another collection called a hash table, right? That would be your non-generic, meaning generic means you get to define the type, right? Like the T. Generic means you get to define the type. Non-generic, you don't. So anyways, access items by list. So key value pair, they recommend dictionary. If you want to access items by an index, so similar to an array, as we demonstrated, you have a list of names, sub-zero. They recommend a list. We're going to get into this. Use of items first in, first out. Use of data last in, first out. Okay, that's stack and queue, and that's the next two items, the next two collections that I'm going to demonstrate. Access items sequentially. We got a linked list. So that's looking things up one after another. And they give you a few more. Okay. What point am I making here? There are a lot of collections. Each one kind of has benefits as far as performance. Right? Ultimately, all these things store data. They just all perform a little bit more efficient or less efficient in certain situations. And so this is an article that you can reference and say, hey, I got a bunch of data. I want to store it. How do I want to store it? And then what collection should I choose? So kind of a neat little reference article. Okay. Again, dictionary for those key value pairs. Certainly over the sorted list. Literally, I could just change this to a dictionary. And I don't think anything changes here. All I did was change my collection, but okay. So another one coming around the corner is this thing called a stack. And stacks do accept what are called generics. Again, generic from our perspective right now just means you could say what kind of data. So, Okay, and so the syntax for creating this concept of a stack is just the same. So what is a stack? Again, these are just collections of data. They all perform better or worse depending on the scenario that you're trying to solve. So how are stacks used? The best way to remember a stack is thinking of a stack of papers. So if you have a stack of papers, here's a stack of papers. I'm putting papers down in a stack. The first one in gets buried underneath the next one, gets buried underneath the next one, gets buried underneath the next one. So if you're going to be putting data in, and then the most likely piece of data you need comes from the top, meaning the last one in my stack is most likely the first one that I'm going to read out. Okay? So if your data that you're working with in your application works in such a way that you're going to be putting data in, but the deeper it is in the stack, the less likely you're going to use it. The less likely you're going to read from it. Okay, that's not a stack. A stack is just the last one in is most likely the first one that you're going to read out. Okay, that's the stack. So when things get added to the stack, they go to the bottom. And then the first one that you read out comes from the top. And if that's the real world problem, if that's how your data would be accessed and used, and okay, that's what a stack is for. Okay, so that's your stack. And let's look at the collection of stack. So here's a stack. We've got the count. Push is our add. So we want to add something to the stack. We're using the method called push. And if we want to then read the data, we use pop. So push and pop are our methods. There's probably a reason why they're called push and pop. I don't know what those reasons are. Like, to add something to all of our other collections, we've used the add method. But here, let's just demonstrate. So here's my data. My data.push. Again, we can add a string now, right? So I'll just, whatever. I'll put my name, my data.push. So I've added 2 pieces of data to the stack. Console.readLine my data.pop. Right line. So because of the way that you read data off the top, the last one in, first one out. And again, just think of a stack of papers and you understand what that means. If I were to do another console.writeLine, my data.pop, you could see Jim comes out first, Evan comes out next. Yep.
So stack is LIFO and then the other one is FIFO?
FIFO, yeah. FIFO, however you want to say it. Yep. So the other one, so that's stack. And again, these are like, what are you trying to do here? You got a bunch of data and you're trying to optimize your application to store it in the best container possible, right? And get the best performance based on the scenario that you're in. And so, I don't know all the scenarios that you in the real world that you could use a stack. You just got to understand what a stack is and understand how data goes in, how data comes out, and that's when that's really efficient. The other one's called a queue. Yeah, and so stacks are last in, first out. Last in, first out. Queues are first in, first out. Okay, and when I think of a queue, I think of I've certainly worked at a lot of entry-level jobs when I was younger, and one of the jobs was a gas station. I worked at a gas station, and I'd load the soda. And where do you load the soda from? You load it from the back, right? So you're loading the soda from the back, and the first one in is the first one out from the customer. And so, that's stack versus queue. Queue of ints, my numbers equals new queue. Sure, we'll say ints are 1, 2, 3. Well, you give me some help here and then you don't. Fine. And you can kind of see NQ versus DQ, right? Add versus read. So if we jump ahead, what are the methods? Well, I actually don't show it, but as you could see, NQ is how to put them in. DQ removes and returns an object at the beginning of the queue. So removes it, so it does in fact take it out. So if the first one in should be the first one out. And there you can see 1 is the first one on the way out there.
Is there anything that happens to the elements in your list that are just going further and further back in the, how relevant they are? Is there something that happens to those? Like, is it dormant or is it?
It's a good question. No, they just kind of,
They still hang out?
they still hang out there so long as they're in scope, you know. So you can see we put them in 1, 2, 3. They come out 1, 2, 3. First in, first out. And again, you know, I think that Microsoft document here is a good thing to throw in. To favorites, they talk about dictionaries, lists, queues, and stacks. Some of the most common collections in C#. Right, very commonly used collections, and they go over some other things like a linked list, access items sequentially, and some other collections that actually we did cover sorted lists. All right, that is the end of the lecture.